Hello, this video illustrates how to write a chess program using WinForm applications in Visual Studio 2022. I'm going to first show you a demo of how the game looks like, and then I'm going to show you the code behind it and tell you how you can improve that. So the game begins by a main form like this, where you have the option of changing the name of the players. Let's say this one is a bishop lover. The second player is crazy knight. And you can set the increment and time limit to different values. Time limit basically tells the program that you have to give every player 3 minutes. In this case, three minutes at the beginning, and they only have 3 minutes to finish the game. The increment value is in seconds, and basically it specifies how much time each player gains by making one move. So originally, when the time limit is 3 and a player plays a move immediately after the game starts, the time limit becomes 3 minutes 2 seconds, because you're going to increase the time limit by that increment every time a player makes a move. Player 1 plays with the light color pieces. Player 2 plays with the dark color pieces. So let me show you the new game. I'm going to hit the new game button. This is basically the outline of the game. On top, I have crazy knight. On bottom, I have bishop lover. That's player 1. Player 2 is a crazy knight. And what you see is the game from the viewpoint of player 1. Now, the players can, begin their game. The first player, bishop lover, can begin the game by moving any of these pieces around. In order to move a piece, you have to grab it using the mouse and then move it anywhere you want and then drop it. So of course I cannot move pawn from here to here. I cannot move bishop from here to here. So as you see, it checks for legality of the moves. I cannot move queen in a way that it jumps over the pawn. I have to begin with a reasonable move, like moving the knights here and here, or this knight here and here, or moving any of these pawns 1 or 2 cells. So I'm going to move this pawn 2 squares forward, and as you see, the game has begun. The bishop lover has a time limit of 3 minutes and 2 seconds, while the crazy knight's time limit is ticking because it's black turn to move. And as you see, this moves is stored here in this list of moves, and the black piece moves this way. And then let's say the white captures the black pawn. Then we're gonna have let's say this move. Then we're gonna have check. As you see, this QH5 plus, the plus means check. Then let's say black has to defend with this only move. Then we have pawn captures, then the other pawn captures, and finally then queen is going to capture this, and that's the end. If I press OK, as you see, it says game is over. It's a checkmate. And as you see, queen captures g6 pawn. will result in a win for white, okay? And the reason is the black king cannot move anywhere, right? Because it is threatened by the knight, by the queen of the white piece, right? Okay, so that's basically a demo of the game that results in a checkmate. I'm going to show you one more demo, but this time with a stalemate result. So let's this time give more time to each player and play a game. I'm going to show you a stalemate situation. So, of course, there's no logic in the game. I'm just going to play some random moves. As you saw, when I wanted to promote, it gave me 4 options and I chose one of them, the queen. As you know, when the pawn of one player reaches to the last rank, which is for white is going to be rank 8, for black is going to be rank 1, then the pawn has to be promoted to another piece. It cannot stay pawn, it cannot become king, it can become a knight, bishop, rook, and queen, and I could choose a different piece, but normally they choose queen because queen is stronger. And let's say the game continues this way. As you see, I have a check. When I'm in check, I cannot move the other pieces. I have to get out of the check either by moving the king, or let's say in this case, I'm gonna use my bishop to get rid of the check. Then game continues. We have, let's say, this. Then we have here. Actually, I have to move the black piece. Then here, then here, then here, then here, then check. Move this here. And then now I'm going to place it here. And instead of promoting to a queen, I'm going to promote to a knight. And as you see, it's a check now. So the king has to move, and we're going to make things a little more interesting now. Maybe let's put this here. Let's put this here. Let's put this here. Let's put this here. I'm just going to play some random moves. And I should be careful not to mate the opponent, because the goal was to create a stalemate situation. So in order to make a stalemate, my plan is to just trade all the pieces and create a situation that results in stalemate. There are many ways to do stalemates. The way that is supported by this application is a stalemate by having no legal move to play. But there are some other ways to stalemate, like having 3-4 repetition of moves, or basically we can have a stalemate by insufficient material, but I don't want to talk about that. Let's just keep going. All right, so now I'm very close to a stalemate. If I put the queen on c7, it's going to be a stalemate. And as you see, it says stalemate, and I press OK. And as you see, this is the list of all the moves. And then at the end, I have a half-half, means the game ended with a draw, and it's a stalemate, right? So that's pretty much the second demo. Now I'm going to go to the code and show you how this can be implemented in Windows for applications. I'm going to close this. What I'm going to do is to first show you the UI, the actual form of the game. And then after that, I'm going to show you the logic of the game. The logic of the game is implemented in this class, chess game. It's a pretty long class. It's made of 961 lines because I tried to make everything realistic and follow not all, but most of the FIDE rules. You don't need to be aware of all the rules. You don't need to understand this part. Chess game should not be manipulated by you for the homework that you have to get the credits. You don't need to change this class. I'm going to explain this briefly after I show you the UI. So this is what we have in the UI. This is the form that will be opened after the user tries to create a new game. There are multiple pieces here. We have a list box, which is going to show you the list of all the moves, as you remember. This is going to be a picture box, which is going to hold all the 64 squares and all the pieces on them. Basically, the way to do this is to just draw multiple lines and fill them with different colors. We do have a timer that's for keeping the time and making sure that the time is counted for both players. Then we have 4 text boxes that are not visible here, but they are here. One is this one. This is for the name of the second player. One is this one, the name of the first player. One is this one, the player 2's time limit. And one is this one, the player 1's time limit. The reason you don't see them is because they have the same color as the background. That's why it's not visible. But, you know, the names are player 2, player 1, as you see here in the properties. This is going to be player 1 time, and this is player 2 time. And that's pretty much the form 1, right? There's the main form where I have to select the players 1 and 2 name, the time limit, the increment, and then the new game. There's a string board setting here that allows you to choose the light and dark color. You can change the light and dark color of squares from the default one, which is, you know, black and white, to any other color you want. You can make one of them gray, one of them green, one of them yellow, one of them blue. I mean, you can do whatever you want. There's a color dialog that will be popped up after you select the light or dark color and lets the user to select any color they want. After all of these not so important details, let's get into the more important details. What I'm going to do here is to show you how the chess game can trigger some events. Like, here are some of the events, like move, like capture, like check, like checkmate, stalemate, castle, and then after the chess game.cs or the class in this chess game.cs triggers those events, how we can handle it in the chessboard.cs, which is basically the form that contains the board. Also, what I'm going to show you is the data binding piece that has to exist between the chess game properties and the chessboard properties. Chess game is the logic of the game. Chessboard is the UI, the one that I showed you. So from now on, whenever I say chess game, I mean the logic of the program. Whenever I say chessboard, I mean the UI of the program. So let's see multiple events that are going to be triggered in the chess game. I'm going to skip some pieces, some parts like this enumerator piece, which is going to have one entity for every piece, and piece none means an empty square. We have castle permissions. We can have castle permission short for the black and white pieces. We can have castle permission long for both black and white pieces. These are not that important. We can have promotion to a black knight, white knight, black bishop, white bishop, black rook, white rook, black queen, white queen, and no promotion. There's a class move that basically represents a single move. It has the coordinate of the first square and the coordinate of the second square. There are some booleans like the ampersand. When you're moving a pawn in the beginning, you can capture it by the opponent pawn in a weird way. We call that ampersand. You don't need to know all these details, but I'm just going to tell you there's a boolean like ampersand. There's a boolean called check for the case where the move is a check. We have checkmate boolean, stalemate boolean, castle boolean. If the move is a castle, castle means the king and rook basically replace they just jump over each other, and king goes to the safety. The castle is either true or false. The captured piece is stored in this property. Moved piece is going to be stored in this property. Promoted is either none if it's not a promotion. If the move is a promotion, it's going to be the promoted piece. And then I have the toString, which represents the move. The constructor is basically initializes the values, and then the toString method basically places the right string for the string representation of the piece. This string is the same string that you see on the blue list box when I was playing the game. So it's quite complicated. You don't need to check out its details. For example, if it's a stalemate, it prints half means the game is in a draw. If it's checkmate, it's either 0-1 or 1-0. It's a decisive result. Check should be represented by plus. And there are other pieces that there are other standards that I don't want to get into them. Then I have this square class. Let me fold this move class first. Then I have this square class, which basically represents a rank, the file of the square of a board. The board has 64 squares. This one represents only one of them. And every square has an occupant. Originally, half of the squares have no occupant, and the other half are divided between the white pieces and black pieces. The occupants of half of them would be white, the other half would be black pieces. And there's a equals method, there's a get hash code method. These are because I wanted to make the square hashable because I stored them in a set. You don't need to know all the details again. Then I have the chess game. Now, chess game is the class that checks the legality of every move and triggers the following events: promote, move, castle, checkmate, stalemate. You need to add more events, like you need to add one more event for check. You may want to add an event for the low time if the time of the player goes below 10 seconds. There's going to be another event. These are all from the chess event, what do you call it? Delegate, which is basically this one, right? Gets a move and basically that would be the event. Now you can handle it using the move that is passed to the event. So what we have next is a 2D array of squares. We call that board. It's an 8x8 2D array. We have a square en passant to null. This is a temporary variable that is used for the en passant move. Castle permissions. Originally, we have all 4 permissions, two castles for the black king, 2 castles for the white king, but during the course of the game, the permissions will be reduced. After, for example, the black king moves, its permission to castle will be nullified. You don't need to know all these details. Then we have white turn set to true, because originally it's the white piece to turn. It's white's turn to move, and then after that, white turn becomes false, and that means it's black's turn to move. Then we have an auto promote to false, as you saw when I was running the game. It wasn't this exact code, but similar code. When I promoted, it gave me some choices. If you don't want to see those choices and you want to always promote to a queen, you can set the auto promote to false. Then I have a time limit for both white and black pieces. These are long variables. They represent the limit in seconds. Then I have, actually, they're going to be more than, they're going to be more precise than a second. They are in second and some fraction. We need to know the time limits in a more precise fashion. So then I have 2 strings, player 1 and player 2 names. Then I have both the white time limit string and black time limit string. These are private. Then I have some public variables corresponding to the 2 private variables I have. One of them is white time limit, the other one is black time limit. As you see, the public one start with a capital letter. There's the private ones start with lowercase letter. This is because I want to define some getter and setter, and in the setter I'm gonna invoke a property change event, because we're gonna basically bind these 2 variables, the white time limit and black time limit, to the text property of the chessboard text boxes for the 2 time limits, to the text property of these 2 text boxes. So the black time limit should be bound to this. The white time limit should be bound to this. This is called player 1 time. So the white time limit should be bound to player 1 time dot text, which is the text property of this text box. Then what else do we have? So as you see, The getters don't do anything, but the setters basically invoke a property change. They pass these two string, this one for the white time limit, this one for the black time limit. And then I have some other methods that are really don't matter. This is a very important one. We have a binding list of moves called moves. And the reason I have it as binding list is because I want to bind this list to the blue list box that you saw in the chessboard, to this one's data. So this one's data is going to be always synchronized with the chess game's moves list. And that's why I have it as a binding list. That's going to make your life a lot easier when you want to bind the list to a UI object. This is the best way to do it. I'm going to show you how to do it. And yeah, that's pretty much it's the time to string. You don't need to call it. It's already called. There are lots of references to it. Most of them is to convert the long white limit and black limit to the white time limit string and black time limit string. So it's basically they are converting a long to a string. And as you see, the time is in millisecond. I told you this should have more precision than a second. So the time which represents the time limit is in millisecond, and that's a long variable. Then it's going to be converted to a string. And the string representation, as you see, it looks like this. I could have done this much easier using a string formatting, but I tried to make it look a little bit more customized and make it look nicer. So I had to write multiple lines of code for it. Then I have the constructor for the chess game, which initializes the players' names and the increment and the time limits. As you remember, the time limit and increment were updated by the user using two numeric up-down button controls. And then, after you do all of that, we have the private checker for checkmate. We have private checker for the stalemate. We have private checker for a check event. And as you see, we're going to use these later. We have a private method called all legal moves. These are used for, finding out whether you have a checkmate or a stalemate, or, they are used for different reasons. I don't want to get into the details of these. We have an overloading version of all legal moves. We have a legal move which checks the legality of a move and has no side effect. We have tri-legal move. We have move methods, which basically is called whenever you move a piece. This one basically is the most, maybe the most frequently used method by the UI, because for every move or capture, you're going to call this one. I'm going to show you how. If I go to the chessboard, which is the UI of the program, if I click on this picture box and go to its move up event handler, you can see that I'm calling game.move somewhere here, actually, right? And that's basically makes the move, right? That's where I make the move. And that's a critical method. As I said, It's going to basically trigger all the events that I mentioned before. It's going to trigger a checkmate if it's a check. Mate, if it's a check, it's gonna trigger the check event. Let me show you. Okay, here it is. It says if it's a checkmate, trigger the checkmate event. If it's a stalemate, trigger the stalemate event. Generally speaking, you have to trigger either the castle or moved events. All the moves except the castling would be different. The reason is I want you to give a different sound to the castle than move or capture. Again, as I said, both move and capture will be triggering this moved event. I didn't put the checked event, but you can just extend this code and say, for example, if move dot, sorry, if moved, what? Why doesn't it let me? All right, so if move dot check, then you can basically call the check with move, but because I have no event for that, it doesn't let me do that. But we do have a check property for the move that you see here, right? Basically, in the case of a check, you have to create another event and trigger that event. Also, you know, if you want to trigger more events, you can do that depending on you know, what the assignment asks you. And then basically, I'm going to add the move to the moves list, and I'm going to swap the turn. If it is white turn to move, it becomes black turns to move. If it's black turns to move, it becomes white turns to move, and then I will return true. True means success in the current move. That means that move was legal, right? If it wasn't legal, then I should return false, and that happens here and here, right? In some case, I'm sorry, here. In some cases, the return false should come after undoing the move. Undo move is making sure that you're not creating any side effect for because of an illegal move to your chessboard or any other variables. So it's a quite complex logic. You don't need to get into the details of it. As long as you know there's a sequence of events that are going to be triggered here, and you're going to handle them in the chessboard event, that's good enough. And then you have pretty much a few more things to see in the chess game. One is set moves to a string. That's a sub procedure for the to a string method. I'm not going to get into it. Complete promotion move. That's also a very tiny part of the game. When the promotion happens, you don't need to be worried about that. We do have an undo move. You don't need to worry about that, and that's pretty much it. It's a 960 lines of code for this logic, right? Because, you know, chess game is a complex game with lots of rules, and I have to make sure everything is in the tip-top shape when you're designing this game. Now, let's get into what you need to do. That's the most important part, right? The chessboard, which is the UI part of the game, is going to take care of all the mouse movements. I'm gonna first show you those a little bit. We have board mouse down, we have board mouse up, we have board mouse move. These basically allow the user to interact with the pieces, grab a piece, drag it, drop it somewhere else, So these event handlers are doing the pretty great job of giving the user a sense of playing with real pieces, because the user can use the mouse to grab a piece and move it anywhere they want. But if the move is not legal, the piece goes back to the original location. Excuse me. So we have board paint, which is gonna paint the whole board every time, and you can check it out if you want. It's not necessary. You don't need to do any changes in the board paint. Also, pretty much no change in the mouse move as well. Mouse leave also. Don't worry about these. You don't need to be worried about them. This is also the timer tick, which basically the tick event handler of the main timer is going to make sure that when the timer ticks, either the white time limit or the black time limit gets updated. If it's white turn to move, then you have to update the white time limit and subtract some value from the white time limit. And basically this is the subtraction that happens. This if is when your time is so low that you're going to lose by a timeout, right? And the other one is for the black pieces, right? And that's for form closed, which starts the timer. About that. The part that you need to do only, is the beginning of this chessboard.cs class. Other than the check event that you have to create, because I don't have a check event for the chess game. Other than that, you don't need to do anything else in the chess game.cs class. You need to do the following changes here. Change 1 is to add more sounds for other events. I only have 2 sound players for move, then checkmate. Only checkmate is used, the move is not used. But you can download more sounds, and for different events you can have like different sounds. You can have one sound for the captured event, one sound for castled event, one sound for promoted event, one sound for check event, one sound for the low time, one sound for the stalemate, right? Try to have like different sounds, so don't make the sound of capture the same as move, right? And then that's the first change you need to do. The second change that you need to do is right here in the constructor of the chessboard. You need to bind the game white time limits to player one time.text. If I run this, it doesn't show me the time. As you see, there is no time here and here. So the reason is I haven't bound these text boxes to the actual times that I have in the chess game class. You don't need to do anything in the chess game class, but in the chess game class, I have a white time limit and black time limit properties that you must bind them to your player one time, player two time text boxes, the text property. And you can do it in different ways. One way is to use the player one time or player two time text box dot binding, the data binding dot add method. That's a very interesting method. It gets multiple parameters and it binds the string game that's white time limits to a string player one time dot text, and then you can do the same thing for the black piece. Another way is to subscribe to the property change event of the chess game, because chess game trigger the property change, you can subscribe to it here and handle the event. And by handling it, you can update the player 1, player 2 time.text properties. The other change you need to do is right here. I have created a move list, which is going to be a binding source, and its data source is set to game that moves. If you remember, the game that moves was a binding list. And I told you it's good to have it as a binding list rather than a regular list, so that you can bind the data of the list to the list box. All you need to do is to assign move that list to the list box 1 dot data source. That's it. So it's a simple assignment. The next change is going to be, because right now, because we haven't done this assignment, you cannot see the list of moves here on this blue sign, right? But when you do it, they're going to appear here, right? It's not going to be a big deal. All you need to do is to do this assignment. The next one is going to be this if-else statement, which you have to complete it. In the game moved event handler, you need to do the following. You need to make a noise for a move and make another noise for a capture. How do you know if it's a move or capture? If move that captured piece is equal to no piece, then it's a move. Otherwise, it's going to be a capture. And if you're wondering how to play the sound, I'm going to show you an example for the checkmate. For the checkmate, this is how I play the sound. I have created a sound player before, initialize it to my checkmate sound, and I play that, right? I'm not sure if you heard the noise that was played when I checkmated the opponent. Then it's going to end the timer because we're going to stop the timer, and then it's going to show that which player won by checkmate. It's either white or it's either player 1 or it's player 2, right? And then we have a similar thing for castle. You gotta make a special noise for castling. Then we're gonna have an event handler for the stalemate. You're gonna have another special noise for the stalemate. Then for promote, you need to have a special noise again. And that's pretty much it. That's all you need to do to complete this. You can get some extra credits by doing the following. After you bind the list of moves to the list box, then the moves appear here. So for extra credits, the user should be able to click on any of these moves on the right-hand side, and by doing that, the user has to be you should be able to show the user that earlier moment in the game where that move was played. So if you want to get extra credit, you need to do that. And yeah, that's pretty much it. Thank you, and I hope that you can finish the implementation of this game.